Hello everybody, this is Mr. Yen, and in this video I'm going to be guiding you through lesson 8.3c, titled Proving Quadrilaterals, and this time we're focused on rectangles and squares. Let's go over some definitions of those quadrilaterals. A rectangle is a quadrilateral with 4 right angles, or 4 congruent angles, because they're all equal to 90 degrees. There's a right angle, here's a right angle, here's a right angle, here's a right angle. Another way that you can think of this is that this side here is going to be perpendicular to the bottom side, and this bottom side is going to be perpendicular to the right side. So all of the sides are perpendicular to their connecting sides. A square is a quadrilateral with, it also has 4 right angles and 4 congruent sides. And remember, congruent sides means same length. So 4 right angles, and all of these sides are the same length. A couple of other things to remember from previous lessons. If two lines, if their slopes are opposite reciprocals, right? Remember, opposite reciprocals are if one slope is A over B and the other slope is negative B over A. These two numbers are opposite reciprocals, right? It's like you're flipping the numerator and the denominator and changing positive to negative or negative to positive. If that is the case for the slopes, then for those two lines, we can say that AB is perpendicular to CD. It forms a 90-degree angle. It's perpendicular. Okay, so in your minds, I want you to connect perpendicular, opposite reciprocal slopes. Perpendicular, opposite reciprocal slopes. And then same from yesterday, if AB and CD have the same length, they are congruent. So I can say AB is congruent to CD. So congruent. In your minds, connect congruent, length, same length, congruent. Perpendicular, slopes are opposite reciprocals. Okay, let's put that into action. Here is the quadrilateral we're given. And the first thing that we're going to do is we're going to find the slopes and the lengths of all of the sides because we'll use that information later. So the slope of AB, that's this side right here, looking from left to right, we're going up 1, 2, 3 units. And we're going to the right 1, 2, 3, 4, 5 units. And then let's also calculate the length for AB next. So I know that this hypotenuse, we'll call that C squared, is equal to the two legs squared and added together. So 3 squared plus 5 squared. So C squared is equal to 3 squared is 9 plus 5 squared is 25. So C squared is equal to 9 plus 25 is 34. So I know that AB is equal to the square root of 34 if I squared both sides. Okay, we have AB. Next, BC, that's this side here. That slope, looking from left to right, it's going down 1, 2, 3, 4, 5 units. And to the right 1, 2, 3 units. So change in Y over change in X. And from left to right, since I'm going downhill, this is a negative slope. It's going to be really important that you keep track of positive and negative slopes in this activity. Okay, now let's jump down to the length of BC. Well, it's a slope triangle with 5 and 3. So I can say c squared is equal to 5 squared plus 3 squared. Notice that's the same equation that I just did here, so I don't need to show all of the steps. I can just jump to the end and say that the length of BC is equal to the square root of 34, because I've shown all the work for that right here on the left already. Okay, slope of CD, that's this side up here. Well, looking from left to right, it's going up 1, 2, 3 units, and across 1, 2, 3, 4, 5 units. So that would be change in y is 3, change in x is 5. The length of CD, it's also a slope triangle with 3 and 5. So it would also be c squared is equal to 3 squared plus 5 squared. I can skip some of the work because I've shown it up here. And so I can say CD is equal to the square root of 34. Now let's do the slope of AD. Let me grab one more color. Orange. This side here. So looking from left to right, it's going down 1, 2, 3, 4, 5 units and across 1, 2, 3. So this is also 3 by 5. So my slope is negative, because looking from left to right, this is going downhill. Negative, change in y is 5, change in x is 3. Length, it's also going to be a 3 and 5 right triangle. So I know the length of AD is also going to be the square root of 34. Okay. Now we have this information, we can use it in our evidence. Is ABCD a rectangle? Well, a definition, quadrilateral with 4 right angles. So let's think about this for a second. If we need to prove that all of the angles in this are right angles, what we have to prove is that each side is perpendicular to its adjacent side. It's the next side, right? If this side is perpendicular to this side, then it would form a right angle there. If BA is perpendicular to AD, it would form a right angle here, and so on. If this side is perpendicular to this side, it would form this right angle, and all the way around. And here's a very helpful hint. If you can prove that these two sides form a right angle and are perpendicular, and I can prove that these two sides in this opposite corner form that right angle, that's actually enough to prove that all of the angles are right angles. Let's do that. So let's see if I can prove this right here, that side CB and BA are perpendicular. Well, I know that the slope of BC is negative 5/3. I know the slope of BA is positive 3/5. 3/5 and negative 5/3. Well, what do we know about those two numbers? They're opposite reciprocals. Okay, so let's put that in our evidence. Slope of BC and what else? What did we say? AB are opposite reciprocals. Guess what? You can say OPP period for opposite. Save you some time. are opposite reciprocals. Therefore, right, we always need a therefore. You can use the therefore symbol, or if you want to write out or type out the word therefore, that's fine too. Therefore, AB, that side, is perpendicular to BC. Okay, we've proven this right angle here. Now, let's prove this opposite corner right angle. Well, that's CD and AD. Well, let's check those two slopes. CD is positive 3 over 5. AD, that slope, is negative 5/3. Those two numbers are opposite reciprocals, so that's what we can say. Slope of CD and AD are opposite reciprocals. Therefore, CD is perpendicular to AD. So now we've proven this right angle. And if we've proven that these two are right angles, that's enough to prove that all four right angles, or all four angles are right angles. So we can say, we can conclude ABCD is, this will say rectangle after I fix that typo. It is a rectangle because it has four right angles. Right, remember, our conclusion always comes back to the definition. All right, that's a rectangle. Now, what about a square? So let's start by thinking about the definition of a square. It's a quadrilateral with four right angles. And four congruent sides. Okay, so let's break this into two parts. Part one is proving that the quadrilateral has four right angles. Well, we know from all of our proof from the rectangle that the slopes of the sides are opposite reciprocals, so it has four right angles. So all I'm going to do for that is I'm just going to take this and just kind of bring that evidence over here, and we'll just say that AB is perpendicular to BC and CD is perpendicular to AD. I'm not going to rewrite all of this stuff about the slopes and the opposite reciprocals because I did that here on the left. So I can just carry it over and then say this here. That's part one. Now let's think about part two. Four congruent sides. How do we prove that sides are congruent? Congruent, same length. So let's look at the lengths. If all of these lengths are the same, then we know that all of these sides are congruent. Well, let's check. This is square root of 34. This is square root of 34, so is this one, and so is this one. All right, so I can say the length are all the same. Therefore, right, all sides are congruent. Okay, so we've proven that it has four right angles because these pairs of sides are perpendicular. We've proven that all sides are congruent because all of the lengths are the same. Now I can conclude that ABCD is a square because it has four right angles and four congruent sides. The conclusion comes back to the definition. Okay. And so that is how you are going to prove rectangles or squares. And with that, I will say goodbye and good luck.